Lecture 1C for the differential equation and Fourier series MT223. This course is offered for the second year student of chemical engineering. In lecture 1B we have discussed various topics in which initial value problem and boundary value problem. Then we discussed developing a mathematical model as a differential equation. In addition, we also talk about the steps of modeling process. Further, we took 3 examples for mathematical model in which differential equation were discussed. We also learned about the method of solution of ordinary differential equation and started the simplest form of differential equation, that is separable equation, and its solution. For separable equation we attempted to solve two differential equation. Now solve problem 3. Example 3. Solve the differential equation x dx plus sec y sin y dy is equal to 0. Now in this differential equation the trigonometric function are involved. First of all, because there are two variables in the given equation, one is x, another one is y, so we have to separate these two variables and their function. As we can write sec x sin y dy is equal to minus x dx. Now collect the function of same variable. On left hand side we must have the unknown variable y, and on right hand side we must have the independent variable x. So sin y dy is equal to minus x dx divided by sec x. We have separated the variables. Now integrate both sides. Integral sin y dy is equal to integral minus x dx upon sec x. We will follow the fundamental rule of integration as taking the negative sign outside the integral. This equation can also be written as integral sin y dy. There is no change on the left hand side, but on our right hand side integral minus x, this is same as previous one, but instead of sec 1 over sec we can write cos x dx. Say this is equation A. Now in this equation on our left hand side there is a function of single variable y. There is single function of y, and on our right hand side there are two function of variable x. So for the right hand side, whenever the integral sign having product of two function, we must apply the integration by parts formula. So integration by parts formula says that whenever we have integral the first function u of x, the second function v of x dx, this can be written as bracket open the first function, that is ux, multiply by the integral of second function, integral of vx dx. This is the first term of by parts formula. What is the first term? The first function write as it is, then multiply it with the integral of the second function. Whatever be the second function, we take the integral of the second function. minus, then integral sign. We now take the derivative of the first function, u prime x, bracket open, then under within the bracket, under integral sign, there is vx dx. This term integral vx dx is same as the term involved in the first term. There is also integral vx dx. Now bracket close, then differential of integral dx. This is the formula for integration by parts. Now in the above question, in equation A, we will apply this by parts formula on our right hand side, and we take the integral of the left hand side by using the formula. The right hand side of equation A can be determined using by parts formula as, now what is the function we have on our right hand side? Function is minus time x cos x dx, right? So this is equal to, take out the minus sign from the integral. Now apply the formula for the function x and the second function cos of x. So according to the formula, we have in the first term the first function as it is. If we consider x is our first function and cos x as our second function, so write here x as it is. Now take the integral of the second function, that is cos of x. So if we take the integral of cos of x, we will have sin x. Now this is the first term of integration by parts formula, minus, according to the formula there is integral sign, then after integral sign we write the derivative of the first function. Here the first function is x, so the derivative become 1, and we write the same integral as we have taken in the first term. In the first term, the integral of cos x is sin x. So write here the sin x as it is under the integral sign, dx, bracket close. Now after simplification, the first term will be same, remain same, x sin x. The second term, integral of sin x, as you know, this is minus cos x. So minus integral of sin x become plus cos of x. And lastly, we introduce the constant of integration on our right hand side. Remember it, always we write a single constant of integration if there are more than one integral term, but we introduce only single constant of integration, that is c here. Therefore equation A, now equation A is in the previous slide, can be written as, in equation A, the left hand side we have cos y, integral of sin y is cos y, is equal to minus the right hand side we have derived on this slide, that is minus time x sin x plus cos x plus c. So here we have minus time x sin x plus cos x plus c. This is the required solution of the given differential equation. Problem number 4. Problem 4 says that solve the differential equation x square y prime is equal to 1 plus y. Here the derivative of y with respect to independent variable, that is x, in this problem is denoted by y prime. This is another way to denote the derivative. So here y prime stand for dy by dx. So first of all we can see that this variable can be separated. So we apply the separable variable method. If we separate the variable denoting y prime as dy by dx, we will have the equation like dy by 1 plus y is equal to dx by x square. Now the variable are separated. If we integrate it, take the integral both sides, we get on our left hand side there is a function 1 over 1 plus y. On our right hand side the function is 1 over x square. So for the left hand side, if we take the integral, we have to use formula number 2 given in the provided list. So we can write the integral of dy by 1 plus y as ln modulus of 1 plus y. Whenever we use the natural log ln, we apply the modulus sign in the argument of the log. So here we have ln modulus 1 plus y, which is equal to, now take the integral of the function dx over x square. This become minus 1 over x, plus there is a constant of integration which is not c here. We can take any small variable, small English alphabets. Here we take small k. Now we will simplify this value to determine the value of y. After applying anti-log both sides, to simplify this equation to determine the value of y, we have to eliminate the logarithmic function on our left hand side. So to eliminate the natural log, we have to apply the anti-log, that is exponential function, on both sides. So when we apply exponential function on both sides, so on left hand side the exponential will cancel out by the natural logarithmic function. So it become modulus of 1 plus y. Now when we apply the exponential function on our right hand side, it will become e to the power minus 1 by x plus k. E to the power minus 1 by x plus k, e to the power sum of two terms. So this can be simplified at e to the power k and e to the power minus 1 over x. What is k in this equation? In the previous equation, obviously k is the constant of integration. So if we write e to the power k, as you know, the value of e is a constant. The constant of integration is another constant. So whenever we have a constant to the power constant, it means we will have a new constant. So we call it here in this problem e to the power k as capital A, and write the remaining function as it is, that is e to the power minus 1 over x. So this is the simplest form of the solution of the given differential equation. Problem 5. There is another problem of differential equation. Solve the differential equation dy by dx is equal to xy plus 3x minus y minus 3 divided by xy minus 2x plus 4y minus 8. Now as the equation is given, it seems that we can't solve this equation by variable separable. It seems, but this is wrong. We will solve this equation by variable separable. How? Let us see. First we separate the variable of the given question by factorizing. This is our given question dy by dx, which is equal to xy plus 3x minus y minus 3 divided by xy minus 2x plus 4y minus 8. Now first of all we have to factorize the numerator and denominator separately, and the question becomes, if we take the x variable from the first two term, that is xy plus 3y x, we can take the variable x, and from last two term we can take minus 1. So in the numerator our factor is y plus 3 and x minus 1, right? Similarly we can do in the denominator, there is xy minus 2x, so we can take the common of x from first two term, and from last two term we can take 4 as a common. So our factor become y minus 2 and x plus 4. So this, the question become in the factorized form. Now dy by dx is equal to y plus 3 multiplied by x minus 1 whole divided by y minus 2 multiplied by x plus 4. Then we can separate the variables. We collect all y and y function on our left hand side and all x and x function on our right hand side. So the variable have been separated. But here we have a problem, that is y minus 2 over y plus 3. We can't solve this problem by any integration formula. So first we simplify this form. Basically you have learned in the previous classes in matrix or interlevel, y minus 2 over y plus 3 is called polynomial fraction. Similarly x minus 1 on our right hand side of the last equation, x minus 1 divided by x plus 4 is another polynomial fraction. Now whenever you have polynomial fraction, if the fraction is proper, then we can solve it. If the fraction is improper, then we can't solve it through integration formula. Whenever we have a polynomial fraction and that hold the the condition that the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator, then this polynomial fraction is called proper fraction. Otherwise, the fraction is called improper. That is the case we have in our last equation. On our left hand side there is y minus 1. This is the polynomial of degree 1. In the denominator we have y plus 3. This is again the polynomial of degree 1. So numerator having degree 1, denominator having degree 1, so it becomes the improper fraction. So whenever we have improper fraction, so we make it proper. And how? Just divide the numerator polynomial by denominator polynomial. As in our equation case, we have to divide the polynomial y minus 2 with respect to by y plus 3, and until we get the denominator polynomial degree greater than the degree of the polynomial in the numerator. Similarly, on our right hand side we have again improper fraction x minus 1 divided by x plus 4. Here again we make it proper by dividing x minus 1 by x plus 4 polynomial. So if we divide, we get the term as 1 minus 5 divided by y plus 3 dy on our left hand side, which is equal to 1 minus 5 over x plus 4 dx. These expression of dy and dx getting after dividing the numerator polynomial by denominator polynomial on both sides. So now we have a form of the equation in which we can take the integral. Now if we apply the integration on both sides and take the integral, here in the first term there is 1, so the integral of 1 is y, minus for the second term we have 5 divided by y plus 3. So our answer is 5 comes outside the integral sign, and we take the integral of 1 over y plus 3 by using formula number 2 in the given list of integral formulas. Equal to sign, then on our right hand side the first term is 1, so the integral of 1 is x, and the second term is minus times 5 over x plus 4. Again we apply the formula number 2 from the list, so we can write minus 5 times ln modulus of x plus 4 plus, here we write instead of c, that is constant of integration, we write here ln c. Ln is the natural log. Why we write here ln c instead of c only? Whenever you have in the solution of differential equation, the natural log are involved in more than one term. So you can take the constant of integration as ln c or ln any other English alphabet, but take the natural logarithm because there are other terms that contain the natural logarithm. This will help us to simplify the solution or the function of the solution of the given differential equation. So use property of logarithm. This property you must have learned in the metric class. A is any constant. A multiplied by natural log modulus of x. If a is the constant and x is the variable, then this can be written as ln x modulus of x to the power a. Now use this property both sides on the above equation. So we write the first term as it is, that is y. There is no change. We just apply the property, set property, on the left hand side second term and on the right hand side second term. So here in the last equation, the first term is y and the second term become minus ln modulus of y plus 3 to the power 5 is equal to x minus natural logarithm again and modulus of x plus 4 to the power 5 plus ln c. So whenever the natural logarithm are involved in the solution of differential equation, we must simplify by using the properties of natural logarithm. There were 4 properties of natural logarithm. Now if we rearrange the term, we collect the natural logarithmic term on our right hand side and call it equation A. In this equation, we bring all the variable without logarithm on our left hand side and all logarithmic natural logarithmic term on our right hand side. Now there are 2 other properties of natural logarithm. Number 1, natural logarithm of modulus of x plus ln of modulus of y means the sum of 2 natural logarithm. So this is equal to the natural logarithm of the product of 2 argument, that is x and y here. This is the first rule. Whenever we have sum of 2 term, it will convert as a product of the arguments. And the second one is whenever we have ln modulus of x minus ln modulus of y. So this is equal to the natural logarithm ln modulus of x divided by y. What is the difference between first and second property? The first is whenever we add 2 term of natural logarithm, so the result will be the product of the argument of the natural logarithm. Second says that whenever we subtract 2 natural logarithm term, so we can write the result as the division of the first one by second. If we use these two properties on the previous equation, that is equation A, so we simplify differential equation as, on our left hand side there is y minus x, so it is y minus x. On our right hand side we apply the two properties, then after applying you will get y plus 3 to the power 5 multiplied by c. See, in equation A and the right hand side of equation A there are three terms. First term and second term are subtracting, first term and third term are adding. So according to the rule, whenever add the two logarithm term, we can multiply the argument of the logarithm. So here we have y plus 3 to the power 5 multiplied by c. This become the product according to the property of logarithm, first and last term in equation A. Now similarly the first and second term, there is a different sign, so the second term must divide the first term, so it appear in the denominator. Now x plus 4 to the power 5. But this is not as simple as we want. We must some other procedure to simplify it, just taking anti-log both sides. To remove the natural logarithm from the equation, we have to take the anti-log both sides. Here for the natural logarithm the anti-log is exponential. If we apply exponential on both sides, it means that both sides appear in the power of the exponential on both sides. For example, in the last equation we have e to the power y minus x is equal to, but on the right hand side there is no natural logarithm or the exponential, because if we write e to the power ln x, then e will be multiplied by ln and there will be only x argument remain. So it become e to the power y minus x, which is equal to y plus 3 power 5 times c divided by x plus 4 to the power 5. Now this can also be written as, the left hand side e to the power y minus x can also be written as e y and e to the power minus x, and the right hand side remains same. So when we write e to the power, here power of e having two term, that is subtraction, so we can write as a multiple of e to each power. Now in the last function on left hand side we have ey e to the power minus x. Now as you know, there is a rule, when the base are same the power must be added. So if we add these two power, e y e minus x, it become e to the power y minus x. So that's why we can write e to the power y minus x as ey and multiply by e to the power minus x. Now we can arrange the term as, on the left hand side y plus 3 to the power 5 e to the power x, which is equal to x plus 3 power 5 ey whole divided by c. Here we solve the equation according to the answer given in the book. We can also solve it otherwise. So after this step, we get the final answer, that is y plus 3 power 5 whole power 5 multiplied by ex, which is equal to, here there is no c. In the previous equation, the c appears in the denominator. Now whenever we have this type of problem in which the constant appears in the denominator, we must want to see the constant in the numerator. So convert 1 by c as c1. We call it new constant of integration name. c1 is the new name of constant of integration. So y plus 3 whole power 5 ex, which is equal to c1 time x plus 4 to the power 5 ey is the required answer. This is enough for lecture number 1. We will meet in the next week inshallah with the new topics. Allah Hafiz.